Hello students, I am Dr. K.R. Jayakumar, Professor and Head Department of Mathematics, KSIT Bangalore. My email ID krjkmaths@gmail.com. So I am doing the module 4 of Engineering Mathematics 4, Probability Distribution and Joint Probability Distribution. We had already 2 classes. In that 2 classes, first we have defined what is meant by probability, some examples, then your syllabus starting with random variable, what is random variable, then in that discrete random variable, then few problems of discrete random variable in the form of applications. Then under discrete random variable, I already told you there are 2 distributions, one is binomial distribution, another is Poisson distribution. So in the last class we have started with binomial distribution, we have derived the mean and variance of binomial distribution and few problems on binomial distribution we have done. So continuation of it, the another question, the number of telephone lines at an instant of time is binomial variate with probability 0.2 that a line is busy. Variate is nothing but variable. So the telephone lines at an instant of time is considered as a binomial variable with probability 0.2. If 10 lines are chosen at random, what is the probability that no line is busy? 5 lines are busy, at least 1 line is busy, at most 2 lines are busy, and the last question, all lines are busy. Recollect the idea. The binomial distribution probability density function is given as P of x is equal to NCX, combinatorics formula, NCX P power x Q power n minus x. Q is nothing but 1 minus P. Now in this problem you can see here the probability they have given 0.2, that is my P value. Q is 1 minus P, therefore it will become 0.8. I am writing probability density function n. If 10 lines are chosen, so n is 10. So 10 Cx 0.2 power x 0.8 power 10 minus x. That is the probability density function for binomial distribution for this problem. What are all the questions they have asked? No line is busy, that means I should take x is equal to 0. No line is busy. 5 lines are busy, I should take x is equal to 5. At least 1 line, this is the most important questions, at least 1 line. So minimum 1 line, that means to the maximum of 10 lines it can be busy. At most 2 lines, that means there may not be, or 1, 2. Then finally all the lines 10. So continuously we put the x values, we can see again I have written P of x is the formula. To get the first result, put x is equal to 0, 10c 0, 0.2 power 0, 0.8 power 10 minus 0. Using calculator, if you calculate the answer, the first one is going to be 0.1074. Then what is the second question? Second question is 5 lines are busy. So put x is equal to 5 in this. 10c5, 0.2 power 5, 0.8 power 10 minus 5, again it is 5. So use calculators, you will get the result 0.02642. Third is the important question. You can see that the third question is at least 1 line is busy. That means minimum 1, from 1 to 10. Already in past 2 classes I am keep on telling this. The calculations are more. Therefore, I can use the formula 1 minus at least 1 P of x greater than or equal to 1. So only one value if you calculate it is sufficient, which is x is equal to 0. I should write 1 minus P of x is equal to 0. So if I use that, already for x is equal to 0 I got the answer. So 1 minus of that, it gives you this result. Similarly, the fourth and fifth. Fourth question is, at most 2 lines are busy, maximum 2. So 0, 1, 2. X is equal to 0, x is equal to 1, x is equal to 2. If you substitute it in this, x is equal to 0 plus x is equal to 1, x is equal to 2. You will get this answer. Last one, 10 lines are busy. Of course, 10C10, which is 1. Here 0.8 power 0, 1. You will get 0.2 power 10, which gives you 1.0247 into 10 power minus 7. That's how we should work. I can show you one more example. That means the difference, until the sixth one we are calculating the probabilities. Now in the seventh one we are going to calculate the number. Probability, it is between 0 and 1. The value cannot be negative and more than 1. But if I say I am finding the number, it can be anything. First I should calculate the probability. The probability should be multiplied by that number, you will get the result. See this. In a large number of parts manufactured by a machine, the mean number of defective in a sample of 20 in 2. So, out of 1000 samples, how many would be expected? They are not asking probability. The question is how many would be expected to contain at least 3 defective parts. So, first n value is 20. Be careful, the mean to be calculated, that means P should be calculated. 20 in 2. Out of 20, 2 will be defective. So, we will write 2 by 20, nothing but 1 by 10, nothing but 0.1. You can see here P value is 0.1. Q is 1 minus P, 0.9. So, this is the probability distribution. 20Cx, 0.1 power x, 0.9 power 20 minus x. What is the question? Out of 1000 such samples, how many would be expected to contain at least 3 defective? Minimum 3. Put x is equal to at least 3. That means 3 to 20, that is 1 minus. Already keep on telling this. 1 minus P of x less than 3. Calculate 0, 1, 2, 3. Put x is equal to 0, then 1, then 2. Add 1 minus. That answer will give you 0.323. Until this we are doing in the last problem. Here out of 1000 such samples, so the probability what you got, it should be multiplied by 1000. So how many would be expected? This is the answer, 323. So please learn the difference between the how many numbers, persons, like that they are asking probability. When they ask probability, it will be between 0 and 1. In other problems there may be some numbers like this. One more example, same way. In 256 sets of 12 tosses of an honest coin, a coin is tossed 12 times in 250 sets. In how many sets one can expect 8 heads and 4 tails? I already told you previously, I think first or second problem we have done on coin only. So if a coin is tossed, probability of head 0.5, 1 by 2, 1 minus 1 by 2, they have taken 12, 12Cx, 0.5 power x, 0.5 power 12 minus x. Now, how many can be expected? 8 heads and 4 tails. What is your P? P is on heads. So I should consider only head, I don't want to consider tail. 8 heads, that means automatically the other will be tails, other 4 will be tails. So in total 12, we consider only 8, because the P, how we define the P, the problem will be based on that. So my probability of P is tossing of a coin, getting a head, so 0.5. Here Q is also 0.5, but P is for probability of head. So 8 head. So I will put P of x equal to 8, 12C8, 0.58, 0.5 over 12 minus 8. You will get the answer 0.1208 multiplied by 256. So that how many can be expected? 31 can be expected with 8 heads and 4 tails. Now final idea of the binomial distribution, you have to fit the binomial distribution. Such type of tables, particularly in the third semester in the numerical methods, you have seen lot of things, Newton's forward formula, backward formula, divided difference, okay. So and even in the third module statistics, you have calculated mean, correlation coefficient, regression lines. So in that such type of x values and frequencies they give. So this is the continuation. That means fit a binomial distribution for the frequency distribution. This is the frequency distribution. Also calculate the theoretical frequencies. X values, random variable values are given for some experiment. They have conducted some experiment. They have given the values x as 0, 1, 2, 3, 4. Then f as 5, 29, 36, 25 and 5. First I should calculate p value. To fit a binomial distribution, I need p, I need n. N I will tell you, here there are 0, 1, 2, 3, 4. Totally how many values? 5. Out of that we consider 4. In any way you can remember. There may be here total number, minus 1 will be the value of n, or sir I am excluding the 0, can I take only these 4? Take it. 1, 2, 3, 4. 0 has no meaning, so exclude it. In any way you see the value of n is 4. Then these all are the frequencies. First I should find sigma f, that means total value of f. Just add the frequencies 5, 29, 36, 25, 5, second line of the table, frequencies 5, 29, 36, 25 and 5, just add those values, you get 100. Another one, sigma fx, that means multiply these two values, 0 into 5, 0, 29 into 1, 29, like that, until 4 into 5, 20. So multiply those values, you will get 0, 29, 72, 75 and 20, total is 196. What is mean of binomial distribution? We have derived NP, the formula from the third semester, mean value sigma fx by sigma f. If I this 196 by 100, it gives 1.96. Then what is my P? Total n, here you see np is equal to 1.96, small equation. From this I should calculate p, p is nothing but 1.96 by 4, that is n, so it gives you 0.49. So my p value is 0.49. Without any hesitation I can say my q value is 0.51 because 1 minus p. So q value is 0.51. Write the distribution. This is what the binomial distribution is. 4cx, 0.49 power x, 0.51 power 4 minus x. Afterwards, what are all the theoretical frequencies? That this probability function should be multiplied by sigma f. Here sigma f is 100. So with 100 I will multiply. That means in the next slide I will show, but just here I am explaining. Put x is equal to 0. Okay, put x is equal to 0 one time. Then x is equal to 1, x is equal to 2, 3, 4. While taking n value it is 4. But while substituting it starts from 0. So 0, 1, 2, 3 and 4. So you can see that x is equal to 0. 100 into 4z 0 power 0, it gives you 6.76. Same way x is equal to 1, 100 into 4c 1 power 1, 26. Like that I have calculated 1, 2, 3, 4, 5. You can see the difference. Here you will get some decimals, but in the problem which is given there is no decimals. But nearby values I think we can find 5, 29, 36, these all are frequencies. I am calculating theoretical frequencies. So theoretical frequencies, it comes to see 6, 27 nearby answers. These all are called theoretical frequencies. So for your reference, one more problem I have given, but I have not given the complete solution. You should work. Find the binomial distribution from the frequency distribution, also calculate theoretical. Here you see 0, 1, 2, 3, 4, 5 is there. So my n value is 5. Here I have written Cx. If you calculate p value, it is going to be 0.57 sigma fx by sigma f. Then this is 0.57, therefore this is 0.43. Then sigma f into this. Start putting x is equal to 0, 1, 2, 3, 4, 5. You will get these answers 1.5, 10 point and exit 5.91. You should work. I have given the complete idea of the problem. So this is the first distribution of discrete random variable. What is my second distribution? It is called Poisson's distribution. So first I have told about discrete random variable. Under discrete random variable, there are two distributions. One is binomial, that's what I have done. Second one is Poisson's distribution, which is also the discrete random variable distribution. What is the probability density function for this? E power minus lambda, lambda power x by x factorial. This is x factorial. Compulsorily x should be greater than 0. X cannot be negatives, even equal to 0 for no distributions, no defective we use it. Equal to is also possible because 0 factorial is 1 I can have, but negatives are not possible. So the probability distribution function is. Here I would like to mention one point. If you understood binomial clearly, we have done the derivation in the last class, mean and standard deviation and variance. Like that, for Poisson distribution also we are going to calculate it, and in the same or in the similar lines which I have done in the previous class for binomial, same way we are going to do for Poisson's distribution. So just the question is, the mean of Poisson distribution is lambda, the variance of Poisson distribution is also lambda. Just to confuse you people, because you people are good in memorizing, correct? So if you memorize like find the mean and variance of Poisson distribution, find the mean and variance of Poisson distribution, like that you might have studied. You should not feel there is some other question they have asked. They can ask the same question in this method also. Prove that the mean and variance of Poisson's distribution are same. The value is both same, lambda. So important derivation in the examination. Now let us do that. So starting with the probability distribution function. So what is the probability distribution function? It is e power minus lambda, lambda power x by x factorial. This is the probability density function for Poisson distribution. Last class we have given the formula. What is mean? That means denoted as mu. Summation of x into p of x. In other words, it is also called expected value of x. This is equal to summation x p of x in this e power minus lambda, lambda power x by x factorial, by x factorial. That's what I said. If you have followed binomial distribution, this is easy. Same thing, x by x factorial, that is 5 by 5 factorial, which gives me 1 by 4 factorial. Example. Like that, this will become summation e power minus lambda, lambda power x by x minus 1 factorial less x factorial, 5 by 5 factorial. e power minus lambda is constant, no x therefore. Summation, this lambda power x, I write lambda power x minus 1 by x minus 1 factorial. 1 lambda is separated. Why? Here denominator x minus 1, the same format I need. So 1 lambda I took outside, so x minus 1. This is equal to e power minus lambda, take this lambda outside, summation lambda x minus 1 by x minus 1 factorial. This is equal to e power minus lambda, expand it. X starts from 0. Be careful, here we ignore one term. See, in the summation what happens, you can leave, you call it as you say it is continuous function or convergent function. So in convergent functions we can leave one or two factors, two reasons. Here I will get negative factorial has no value. Therefore when x is equal to 0, I leave this. Then next value is, it is from x is equal to 0 to infinity. So when x is equal to 1, anything power 0 is 1, 0 factorial is also 1, plus x is equal to 2, lambda by 1 factorial, x is equal to 3, lambda square by 2 factorial, like that I can put until infinity. This is well known series. What is the series? It is e power lambda. That means e power x, 1 plus x by x factorial, x square by 2 factorial, etc., which is e power x. So like that e power lambda. Now what happens? These two combine together. E power minus lambda, e power lambda, e power 0, 1. So my answer is going to be lambda. So I got the mean of Poisson distribution as lambda. Simple derivation. This is what same thing we have done in the binomial also. Just I am telling you, here x by x factorial, that also we have simplified there. Here also we have simplified. Then one more point, don't get any confusions here. One factor we have left because I will get negative factorial. So what I have derived? I have derived the mean of Poisson distribution, which is lambda. Second one, I will take up the variance of the distribution. Variance, sigma square, e of x square minus e of x whole square. All these formulas in the last class we have given. What is this? E of x square, summation x square p of x minus, already I got e of x, which is lambda whole square. Now for format purpose, x square, last time also we have written, we simplify this or we rewrite this as x square as x into x minus 1 plus x. What happens? X square minus x plus x minus x gets cancelled. I will get only x square. Same idea again I am repeating you, I am telling you, binomial distribution. So summation x into x minus 1 p of x plus summation x into p of x minus lambda square. Again this is what we have calculated as a mean value, lambda. So this is equal to summation x minus 1 p of x plus lambda minus lambda square. This is my first equation. Now I want to simplify only this. I will take that one. Consider summation x into x minus 1 p of x, summation x into x minus 1 e power minus lambda, lambda power x by x factorial. Here two terms. Again, if I have 5, 4 by 5 factorial, I have two terms. So 5, 4, 5 factorial, it will be 1 by 3 factorial, two numbers less. Like that, summation e power minus lambda, lambda power x by x minus 2 factorial. Here x minus 2, I should have here also x minus 2. So lambda square, that means e power minus lambda outside, lambda square, lambda power x minus 2 by x minus 2 factorial. So this is e power minus lambda, lambda square summation x minus 2 by x minus 2 factorial. So just here I will write. So if I expand this, here I should leave two terms. When x is equal to 0, minus 2 factorial, no. X is equal to 1, minus 1 factorial, no. So it starts from x is equal to 2. See, in an infinite series, I can leave one or two terms, the convergence will not be affected. Okay, therefore two terms we are skipping it. Therefore e power minus lambda, lambda square into 2, that means anything power 0, 0 factorial. 3 minus 2, 1, again I will get the same series which I got in the mean formula. This is e power lambda, so e power minus lambda, lambda square, again e power lambda. These two combined together gets cancelled, I got answer lambda square. Now before writing, just you can see here, this is my first equation, this is what I considered. What is the answer for this? I got lambda square, I will substitute here. So lambda square gets cancelled, I got the answer as lambda, which is the variance. Okay, so let us complete it, because I will write here, using 2 in 1, using 2 in 1, variance is equal to, that is sigma square, lambda square plus lambda minus lambda square, which gives you the answer lambda. Okay, which gives you the answer lambda. That's what, whether you take the mean value or the variance value, it is same lambda. Of course, standard deviation is nothing but root of lambda. So the question will be, find the mean and variance of Poisson distribution. In other words, prove that the mean and variance of Poisson distribution are same. We have proved the mean of Poisson distribution is also lambda, the variance of Poisson distribution is also lambda. So one distribution if you have followed clearly, then other are going to be easier. Now let us do few questions just like we have done for the binomial distribution, the problems on Poisson distribution. First question, it is easy, therefore I am showing here itself. Find the Poisson probability distribution function which has mean 2. Also find p of x is equal to 4. So the mean value is given, just now I have proved mean value is lambda. So in this problem it is given lambda is equal to 2. So I am writing the probability density function e power minus 2 2 power x by x factorial. I should put x is equal to 4. 2 power 4 by 4 factorial. The answer is coming to be 0.0902. See one thing, in the few textbooks, the answers are given in terms of e power minus 2 only. Please don't write the answers like that, because in calculator it is available, you can find the exponential values. So completely calculate this function for this problem example, putting x is equal to 4, because in a calculator you can type everything. So e power minus 2 power 4 by 4 factorial, which gives this result 0.0902. Don't write the answers in terms of exponentials. We want the complete answer, because to see that the probability lies between 0 and 1. Now the second problem. If 1% of switches manufactured by a firm are found to be defective, find the probability that a box contains 200 switches, no defective, 3 or more defective switches. From this problem onwards, you can find, I am going to use the idea of binomial distribution also. Here see what is the difference. In the first problem they have given mean itself. In the first problem, just an example I have shown, directly mean they have given 2, lambda is equal to 2. But in this problem, second question, mean is not given. They said 1% of switches manufactured by a firm are found to be defective. Find the probability that a box contains 200 switches, no defective, 3 or more defective. Please note that they are asking find the probability. So 1%, that means P is equal to probability of defective. Probability of, last class also I told, please define your P. Probability of defective, it is 1%, that means 1 by 100. And n, capital N or small n, anything. What is the n value? They have given, they have taken 200 switches. 200 switches. I am finding mean here. Please note that in binomial it is NP. In the Poisson it is lambda. I took both. When the probability n is given, I must calculate lambda using this formula. This is the mean value of binomial distribution. So what happens? 1 by 100 into 200, automatically the value is 2. My lambda is 2. So what is my P of x? E power minus 2, 2 power x by x factorial is my probability density function. What is the first question? No defective. Put x is equal to 0. That means we should write the probability of no defective. Don't write answers directly. Every class I am telling, you should define and then write it. So the probability of no defective, for that I should put x is equal to 0. What happens? E power minus 2, 2 power 0 by 0 factorial. The answer is coming to 0.0183. This is the first question. What is the second question they have asked? Second question, 3 or more defective. P of x greater than or equal to 3. That means 3 or more defective probability. That's what we are used to tell again and again. Greater than or equal to 3. I cannot reach until 200 and I cannot do the calculations. So what should I do? 1 minus P of x less than 3. That means 1 minus P of 0, 1 and 2. There is a very useful formula in the probability distributions. So I cannot calculate starting from 3, I cannot go until 200, I will less than 3. So 0, 1, 2, 3, 0, 1, 2, sorry. Calculate 0, 1, 2 with 1 minus 0, 1, 2 in this you have to substitute, find all the values, 1 minus, you will get 0.7621. So here we are asking the probabilities. This is the idea of the problem. Very important one, lambda I have calculated as NP, mean value of binomial distribution. One more example on the board itself I will show you. See that the problem, 10% of the tools produced in a certain manufacturing process turn out to be defective. 10%, okay, 10% are defective. 10% are defective. Find the probability that in a sample of 10 tools chosen at random, exactly 2 will be defective. Exactly 2 will be defective. So, what is my P again? Probability of defective 10%. That means 10 by 100. We are writing very clearly. Okay. Then N value is 10. So, mean again lambda NP 10 by 100 into 10. Therefore, my mean value is 1. What is the probability distribution? E power minus 1, 1 power x by x factorial. That's all. The question is exactly 2 will be defective. So, P of x is equal to 2. That means exactly 2. Exactly 2 defective probability. So, put in this x is equal to 2, e power minus 1, 1 square by 2 factorial. So, your answer is going to be 0.18. Okay, 0.18. This is how we should work in the Poisson distribution. Very important one, they don't give mean, they give probability and n, number of iterations or tools, whatever it may be. Multiply NP, that is going to be your lambda. Like that, we can see so many examples. If the probability that an individual will suffer a bad reaction from injection of a given serum is 0.001, out of 2000 individuals, how many? So, 2000 is my n, 0.001 is my p, this is my p, this is my n, multiply, I will get lambda is equal to 2, np is equal to 2, nothing but lambda is equal to 2. So, exactly 3, more than 2 will suffer bad reaction. So, first what happens, 2 means e power minus 2, 2 power x by x factorial. Exactly 3, put x is equal to 3, you will get the answer 0.18. More than 2, that means here be careful, more than 2, greater than 2, starting from 3. But starting from 3 until 2000 we cannot go. So, 1 minus that formula we use, x is equal to 0, 1 and 2 is also included here. More than 2, x greater than 2, so less than or equal to 2, 0, 1, 2. You will get the answer 0.323. All these things should work. Same way as we have done in the binomial distribution, here finding the number. See this, in a certain factory manufacturing razor blades, important university question, there is a small chance 1 by 50 for any blade to be defective. The blades are placed in pockets each containing 10 blades. So, my n is 10, probability is 1 by 50. First I should calculate mean, 1 by 50 into 10 You see here I have given lambda value 0.5. Now come to the question. Calculate the approximate number of pockets. It is not the probability, they are asking the number. So containing no defective, one defective, two defective in a consignment of 1000 pockets. The second one is the critical question. Also calculate the approximate number of pockets containing not more than 2 defective blades in a consignment of 10,000. Just to confuse you people, that's all. Here also they have given 10,000, here also they have given 10,000. If they have given the question directly, not more than 2, which is sufficient. Just in probability, that's what in the beginning itself I told, English. They can play with the English language so that they make the confusions little bit in the questions. So also calculate the approximate number of pockets containing not more than 2. That means it's continuation. No defective, one defective, two defective, more than 2 defective. So as I already told, my lambda value is 0.5, e power minus 0.5, 0.5 power x by x factorial. By x factorial. No defective, put x is equal to 0. You will get some answer. Multiply that by 10,000. That probability into 10,000, which gives 8187. Same way, one defective, put x is equal to 1. Then multiplied by 1637. 2 defective, put x is equal to 2. Multiplied by 10,000, the answer 163. Finally, not more than 2 blades. Not more than 2. That means less than or equal to 2. 0, 1, 2. Here it is not 1 minus. Same answer, we can add it up. Okay. Not more than 2. If it is more than 2, question is different. Not more than 2. That means less than or equal to 2. So only 3 values 0, 1, 2. You add 0, 1, 2. You add 0, 1, 2. You will get the answer. Multiplied by 10,000. You will get 12. I have given the answers. You can see some clues like I can also give. No defective. The probability will be 0.8187 because since you are going to be multiplied by 10,000. Similarly 0.16, 0.16, 0.0012 you may get the answers for the questions. Multiplying by 10,000 you will get these results. So first 4 questions to find the probability, fifth one to find the number, approximate number. Same way one more problem to find the approximate number only. The number of accidents in a year. The number of accidents in a year to taxi driver in a city follows a Poisson distribution with mean 3. We are happy, directly mean value is given, so lambda is equal to 3. Out of 1000 taxi drivers, find approximately the number of drivers with no accident, more than 3 accidents. That is why here I have not mentioned the lambda value. It is directly given, lambda is equal to 3, mean. Write it, e power minus 3, 3 power x by x factorial. First question, no accidents, put x is equal to 0. You will get e power minus 3, that is all. X power 0 is 1, 0 factorial is also 1. Calculate that answer. To find the number of drivers multiplied by 1000, you will get 50 as the answer. Then more than 3 accidents in a year, so he is committing more than 3. Here again 1 minus formula you should use, less than or equal to 3. 1 minus 0, 1, 2, 3. Add, subtract with 1 minus, you will get some number in the decimal. Multiplied by 1000, you will get 350. This is how you can find the number. What I would like to mention here, in this problem, don't get confusion with 3000 because in the examination what I am finding, people take, because previous problems you have done sir, so n is equal to 1000, no. They are asking out of this 1000 how much. Same way in the previous question also you can see 1 by 50 is the probability, 10 they have given. Out of 10,000, this is not n, this is n. That is why two kinds of problems I am showing. This is p, this is n. You are finding lambda here, then calculating, multiplying by 10,000. But in the next question, directly the mean is given, find the probability multiplied by 1000. Finally, as we have done the binomial distribution, we have to fit a Poisson distribution also. Same lines, there is no change in the method, only probability density function will change. Here we take Poisson distribution formula instead of binomial. Fit a Poisson distribution for the frequency distribution, also calculate the theoretical frequencies. 0 to 4, so my n value is 4, beginning of this class only I told, anyway you can take 0, 1, 2, 3, 4, that means 5 value minus 1 or excluding the 0, 4, these all are the frequencies. So first find the summation of the frequencies, 122, 60, 15, 21 turns out to 200, then fx multiply 0, 60, 15 into 2, 30, 6 plus 4, so 0, 60, 30 turns to 100, mean np, sigma fx by f, it is 0.5. I told you this np is nothing but the lambda, so my lambda value is 0.5. So what is my distribution? P of x is equal to e power minus 0.5x by x factorial. How to calculate the theoretical frequencies? Sigma f p of x, sigma f is 200 here, e power minus 0.5x by x factorial. That is what I have done in the beginning of just in this class only. Here I have used binomial, now I am using Poisson, that is all. Put x is equal to 0, 200, e power these two will become 1, so 121.3. Put x is equal to 1, calculated 60.65. X equal to 2, this is 15.1625. Then x is equal to 3, this value is same, e power minus 0.5, so 2.527, finally x equal to 4. So these all are the theoretical frequencies, 121, 60 point, 15 point, 2.5, 0.319. So you can see almost similar to the given, here 122, 60, 15, correct? Go there and see 121, 60, 15, almost last value is 0.0, so you will get the nearer values which has theoretical frequencies. One more example you have to calculate. What is the value of lambda? Here you can see 0.7825, it is going to be lambda value, again 0, 1, 2, 3, 5, so my n value is going to be 5. Here the frequencies, as usual find the mean value 0.7825, so e power minus 0.7825 power x by x factorial. Then sigma f, total of this, multiply with this, so we take x is equal to 0 onwards, x is equal to 0, x is equal to 1, 2, 3, 4 and 5, calculate these values. Not exactly same, at least nearer values you may get it. Here too many decimal places, 4 we took, if you take 0.783 also we can take 3 decimal places, because power of that you are going to use it, so 3 decimal places also we can take, so we get these as the theoretical frequencies. So these all are the ideas. One more theory question is there. Prove that the Poisson distribution is the limiting case of binomial distribution. You have to take the binomial distribution and prove that it is Poisson distribution by taking the limit of it. So finally I will show you that. quickly we can. So what is the question? Prove that the Poisson distribution is the limiting case of binomial distribution. What is the binomial distribution probability function? NCX P power x Q power n minus x. Here we are giving the justification how we can take the mean value NP as lambda. Now this is nothing but writing x factorial NCX formula. N into n minus 1 etc. n minus x minus 1 into p power x q power n minus x. Take n outside. Here also n. 1 minus 1 by n. Again 1 minus 2 by n. N. If that like that I will take n outside. 1 minus x minus 1 by n by x factorial p power x q power n minus x. How many terms are there? See, starting from this 1, n minus 1, 1, 1, 2, 3, 4 etc. I have x minus 1, one more term n. So there are totally x terms. So n power x 1 minus 1 by n, 1 minus 2 by n etc. 1 minus p power x, this I am changing q power n by x factorial q power x, q power n minus x, q power n here, q power minus x in the denominator. These two are combined together, np. So I can write np power x 1 minus 1 by n, 1 minus 2 by n etc. 1 minus x minus 1 by n into q power n divided by x factorial q power x. So let me take np is equal to lambda. Let np is equal to lambda. I got 50% of the answer. Lambda power x, x factorial. Now what is your q power n, which is nothing but 1 minus p power n. From this what is p? It is lambda by n. So this is equal to 1 minus lambda by n power n. Adjusting 1 minus lambda by n power minus n by lambda to the power minus lambda. All these things you know from the lower classes. A power m n, it is going to be a power m n. If these two multiplied, lambda gets cancelled, minus into minus become plus, this is n. So now it is very clear, it is the limiting case. I know np is lambda. As n tends to infinity, this limit is e power minus lambda, because this value is e in the first semester indeterminate forms or second semester indeterminate forms, you learn it in that this limit is e. So e power minus lambda. Now I am showing, just you see what happens as n tends to infinity, this will become 0. So here I will get 1, here also I will get 1 etc. Here also I will get 1. So this total product is going to be 1. This is lambda power x. Q power n, it has become e power minus lambda. Q power x, it is also 1, because q power x is equal to 1 minus p power x. So tends to 1 as p tends to 0. So what happened? Automatically this is lambda power x, this totally it is 1, q power n, it is e power minus lambda, only x factorial, this has become 1. So what is the answer you got? Same p of x is equal to np, that is lambda power x, these things are 1. This is e power minus lambda by x factorial into, this is also 1. See that e power minus lambda power x by x factorial, I got it, which is nothing but our Poisson's distribution. So that's why in the problems we have used NP as lambda. So it shows clearly the Poisson distribution is the limiting case of binomial distribution. So with that, the distribution Poisson, it is ending. So in the next class we will see the continuous distributions. So any queries you can come with the mail krjkmaths@gmail.com. Thank you.